Clinker Factor, the cement industry podcast.
Welcome to the Clinker Factor, a podcast from WCA, which looks at the cement industry's response to climate change around the world and other topics of interest. I'm Ian Riley, CEO of WCA, and your host on the Clinker Factor. So today I'm talking to Berkan Fidan. He's process director at Oyak Cement and has been in the industry for 14 years. And we're going to be looking at LC3. So I'm sure that many of you will be familiar with LC3, a product that's been developed primarily at the École Polytechnique in Lausanne, and a product that has the potential to significantly reduce clinker use by using a blend of metakaolin and limestone as a cementitious material. So Oyak Cement, through a subsidiary Simpor, has built a plant in Ivory Coast, and I'd like to talk to Berkan about that today. So Berkan, welcome. It's good to have you on the podcast. Perhaps you could give us just a very short introduction of your background and how you came to be in the cement industry.
Yeah, thank you, Ian. Thanks for that invitation and the door. My name is Berkan Fidan. I'm the Performance and Process Director of Oyak Cement Concrete and Paper Group. And I have been in cement industry till 2007. I'm a mining engineer. Then I did my graduate on cement engineering, and also I did a master degree on business administration. I worked nearly 11 years in a cement plant. Now it belongs to Oyak Cement Group. It's Denizli Cement, from engineering chief production manager. And then at the end, I did 1 year plant manager position. And then I moved to just the central office, the headquarters of Oyak. And we, according to our aim and group strategy, we are planning to just expand them globally.
Yeah. So I think that the recent project, the LC3 project in Ivory Coast, is a very interesting expansion and a very interesting project for the cement industry. As far as I know, that's the first plant that's been purpose-built, I think, for LC3. I believe Argos is producing some LC3 in Colombia, but that was in an existing plant. Is that correct?
Yeah, that's the first greenfield plant. We then directly aim to produce calcined clay blended cements with integrated calcined clay line and also a grinding unit in it, and we just built on greenfield.
So can you tell us why you decided to do the project in Ivory Coast?
Yeah, the idea is just calcined clay became much more popular, but it's 3 and 4 years ago. We had first started to investigate on it. And we realized that there are many studies, academic applications, tests, pilot issues available. And on the background, there are also some producers just converted some lines, especially in South America. They did some trials, old stopped kilns, they tried to produce. And also metakaolin industry, it's not an unknown industry. It's also known mineralogical processing industry. And then we just realized that to gain some experience and to improve our ability, we decided to directly do an investment. At that period, Africa, especially West Africa, one of the biggest exporting market for us. We are sending many Turkish producers, just sending cement, clinker to that region. And also when we just analyzed that in that West Africa, the limestone content, it's not available. It's just at sub-Saharan region. There's a deficiency like that. But on the other side, when we looked on the other opportunities, the kaolin and illite-based some clay minerals are abundantly available. In some regions, it's really a high amount of material. The main structure is like that. On the topsoil, just under the topsoil, on the subsoil part, it's a clay reserves. It's up to 10, 12 meters thickness. Then after that, a bedrock with granite formation. When we realized that, we just checked that region, not only the Ivory Coast, with the West African region, analyzed. We did just evaluation and the test, getting samples to analyze that. And also at the meantime, marketing and market potential, population, urbanization is also other issues. on that point, it's just we decided some countries, and the Ivory Coast is one of them. It's the first we decided to go. Then we decided to go with Ivory Coast to establish that plant in here, because all the clinker just imported, they got it from other companies. There is also a port and city. It's a big city in this region. There are some also trading activities still available.
Okay, and could you explain a little bit about the configuration of the plant? What does it look like? So presumably you don't have a kiln, a limestone kiln there, but you have something for the metakaolin. Is that right?
Yeah, just based on the simple preparation unit, it's just the main material. It's clay, as we know, it's a moisture-containing material, and you need to prepare and just make it as much as homogenized to do it. Then there is a pyro process on it. It's a coupled, it's drying process, and then the dehydroxylation process. By the way, additionally, we named as it becomes a brand name. It's just we say is that DOH clay. It comes from dehydroxylation reaction. Then the dried dehydroxylated clay, you remove water. After that, there is a cooling process. Then after that, it's just storing and mixing and grinding.
Is the calcination a rotary calciner, or is it a flash calciner that you're using?
No, that one it's rotary kiln part, just from inlet to rotary kiln, based on rotary kiln design. The second project, it will be commissioned at the beginning of next year in Cameroon. It will be a flash calciner. That one is also the world's first industrial scale flash calcined clay project.
And the raw material is the kaolin is very local to the plant, is it?
Yeah, we positioned the plant according to that. As I said, the evaluation and survey analysis around that. There's a region around that Abidjan region. We detected some zones, critical parts, just mineralogical composition, their reactivity, fineness. Some mineralogical characteristics are critical, not only about the strength values, also about your process, heat consumption, then grinding states, all affected from the typical characteristics of the clay. You may find that the kaolinite with high contents, it may not work due to some additional impurities like quartz or other things. There need to be a decision about and a good receipt need to be catched, and it should be stable. That's the critical part. And it's a tailor-made issue because clay formations are not standard like that, just pure ores like limestone or other things. There are many mineralogical compositions and due to their formation. And the process is also not based on crystallization. It's just only removing of water, not changing the formation of mineral formations in it. That also critical to decide it. And it's just as the beginning, as I said, that's the part we wanted to gain experience. Now we are experiencing that part.
And what's your average haul distance from the quarry from the mine to the plant?
Yeah, we prefer not far away than 10-15 kilometers away. We try to keep it on that boundary. The ideal one is not to go away 100 kilometers. It just can be a limit for calcined clay operation. In Abidjan, we have a chance to do it. We are near to that region, but up to 100 kilometers, it can be said that feasible because you're just carrying water and also the other issues. It should be feasible. That's the issue about clay.
And so the plant you commissioned last year, if I remember rightly.
Yeah, in August of 2020.
So you have now getting on for 6 months of production. And how has the customer acceptance of the product been?
Yeah, at the beginning, we need to do some trials and industrial tests on it. It takes some time after commissioning. We produced calcined clay and we did some tests before just serving it directly to the market. And also there's a licensing, a certification issue, you know that. And we got the first certificates in Africa, SAM2M QL. Q is the calcined clay and EN 197 standards. And the other one is SAM4BQ. We got the first calcined clay added certificates. These are the first products in Africa. Now we are just presenting them into the market. It's just we start with small scales to some ready-mix suppliers to give them to try it, some brick producers. We did some tests with them, but now it's just, especially beginning of the second quarter of this year, we just focused on more, and because we just also just prepared some advertising and just giving knowledge about that product to people, because it's changing clinker, it has a cost advantage, but besides that, all we know that the environmental issue is something, the most important one, carbon dioxide. Yes, there is not a tax or transitions, just a system not available in Africa, but whatever it is, it's just, again, we just decreasing that amount of carbon dioxide. And additionally, that it is more local product than the others. Our just motivation is like that, because we're using directly a local material in here. Now we are just telling that one to the customers and the people. The first impact, it's promising. We try to keep the quality as well as possible. There are some adaptations also required about like water demand, slump, and other things, the workability of that material. We are still working on it, and we believe that it will be much better, and we could increase the content of calcined clay more than as expected.
So you expect to reduce the clinker factor below 50%? Is that right?
The aim is like that, but the problem is that the standard limits. It's just, as you know, that it's the only available ones. These SEM2B Q-type and SEM4B Q-type, and there's also an option with SEM5, but SEM5 need to include slag or fly ash. The advantage of our site, our group has a huge slag potential. We are planning also to focus on that product at the next stage, but currently we are limited according to conditions of EN standard, actual EN standard. We are waiting the revision and the other thing. That's also a disadvantage, not fits with the LC3 original receipt, because it's based on 35% calcined clay, 15% limestone. It's not possible with current standards.
So in the Ivory Coast, the standards, it's all European standards that are being...
Yeah.
And do you sell the calcined clay or the calcined clay and limestone mixture as a product, or is it all sold as cement, as a ready blended product?
Yeah, we are selling as a final product, and also it's also not easy to say it, because it should be managed in a plant. It's not like fly ash or GGBFS like slag, because their composition is known. They can be used in it, but there's also clay is not so stable. It may change. It process is not easy. Grinding issue is different. The chemical composition can be seen as just stable, but the granulometry and grindability of particles may change. That affects so much about the product. It should be controlled in the plant and managed directly with the clinker addition. It's not easy to say that, just sell it as a different cementitious material separately.
Yeah, and you mentioned this having a local product is something that customers value. Is the limestone portion, is that being imported, or have you been able to find sufficient limestone locally?
Yeah, it's imported from the options from Europe, but also from the North Africa. There are options we are getting. All the other suppliers are doing that one, because there is not any other material available. There are some options to add it for minor additives in here, but the limestone, all the limestone, just from the import.
Right. Yeah, I mean, the closest clinker operations would be in Nigeria, would they?
Yeah, the biggest in Nigeria. There are some in Togo, Senegal, and the northern part also.
And so with the experience that you've got to date, you're still very optimistic about the product's potential. How do you see LC3 playing a role within Oyak's portfolio in the future?
It's very critical for us, because after that we have one foot in the Europe with Simpor in Portugal. We are on that market. In these days, it's reached more than 40 euros per ton. It seems like it will increase. Benchmark level decreased. There need to be something done. It's just everyone looking for options. Alternative fuels, yes, one option, but it's the only 35-40% of total CO2 emissions comes from combustion. The other part, in-process details. There are many issues about raw material study, but it's not that amount of raw material without carbonates is not so easy to find. Some lucky plants can do it, but it's not so easy. there are only the most effective two ways is available. One is the still improving and innovation required carbon capture issues, oxyfuels and other things. It's one stage, everyone just spending their time, efforts on it, but there needs some time to make it expand the industry much more. Still some pilot applications are going. On the other side, the second one, it's the calcined clay. It's just or supplementary cementitious materials, not only calcined clay. As far as I remember, when compared a 2-degree scenario and the reference the environmental agencies reported, the main four cases, it's just the first one is the nearly 50% of decrease can happen with carbon capture and just with the reduction of carbon dioxide. It's with that technology. The second one is around 37% of portion can be done by replacing clinker as much as possible. On that part, the options was very available, like slags, steel slag, blast furnace slag, fly ash, and other things. But like we are living in Portugal and also in all Europe, that plants also still close, and just that the amount of slag start to decrease. Fly ash, people couldn't find it easily. It will also decrease much more. At the meantime, cement production increases. It will not be like that in the near future. People are looking for a substitution material. The only thing, it's just fillers. Yes, it's huge amount of fillers like limestone and some other portions, but they are not so reactive. You can add it at the level, and also all plants are doing that. But there need to be go step forward and much more addition required. Then a reactive material is required. Then calcined clay seems like the best option, and we believe that it's next 5 years and 10 years in another long term, it will be much more critical. And our strategy also based on that Abidjan plant and also Cameroon plant will be our R&D, and not only the business side, it's also an R&D and just experiencing part. Our main targets is also just Europe, not exactly in Turkey. Turkey has a chance about that the just natural puzzolans also abundantly available. There's also still slag and fly ash options are still available. Because of that, it's not so feasible now in Turkey, but maybe after just 10, 20 years, it will also become important.
But you would see it as being feasible in Portugal in the near future?
Yeah, it seems. After that, rising up the CO2 issues, just depleting fly ash, slag, and other things, not only in Portugal, all around Europe, it will be much more critical.
Yeah. Okay. Have you looked at carbon capture technology and compared that? Presumably, that's much more expensive under the conditions today than using LC3.
Yeah, it's not. There is not a exact technology is not available. As you know, there are some studies. We are also attending with Simpo about that project. Some of them, like oxyfuel, closed circuit, like the Leylak project in the second phase started. Simpo Portugal is a partner of it. We know also that project. We are also attending some Horizon 2020 and just Green Deal projects on it. We try to attend to get into the projects to understand how can we invest on it. We are also just in one side, we are looking on it. But as you said that, it's not so easy to just scale up it to do it. There are some trials and some pilot applications still available, but they need some time. And also it's so expensive with current market situations and the other issues, it's still expensive. It will be, it's just in a midterm period, it will become just expensive. But till that part, there need to be a quick and easy solution is required. And the main source is clinker for that CO2. If you can replace it, it's much more easy. The other part can help us much more. We can capture the left part, and much more green cement can be possible.
I think that one of the things that struck me in the last 6 months is that there's been a big change in the attitudes of people that I've talked to in different industries, not only cement, towards climate change and towards the urgency to take appropriate steps. One way in which the cement industry can be encouraged to go down that route is with carbon pricing, as we have in Europe. But another possibility is that the market starts to demand it. And we see that in lots of markets, there are customers who would like green cement or green concrete, but they're not really willing to pay for it. I mean, we see in Sweden that people are willing to pay a premium, but it's quite unusual. You know, there are very few markets where you see that premium. And there are some initiatives, for example, in the US, in New York State, to offer an incentive for public procurement, you know, to purchase green products. I wonder if you're seeing in the markets that you serve a change in the customer attitudes towards green products, and whether or not you start to see customers willing to pay some premium, albeit a small one, for lower carbon cements and low carbon concretes.
Yeah, I agree. It should be. These are good attempts, and it's not easy because it's, as you know, that the biggest producers. It's also like in Turkey. Now it's because we don't have a just CO2 tax or payment is available. We are just measuring our CO2 emissions, other thing. We are waiting it, but the cement is a bulky material and it's cheap and can be just sent easily. If someone can do it, the other can just penetrate easily to that market. It should be done in consolidated basis. But as you said, it's part by part. It starts, I believe, by the help of governments and that pressure. It's the natural pressure. It starts. Previously, it was like a sustainable and like a marketing issue, something. But it, as you said, becomes much more critical. People just looking, start to look on a different way. It's not just sustainability, company culture, or other thing. It will become an obligation. And by the help of governments, I believe that also the customers' idea will change.
Right. Perhaps I could just change track a little bit and go back to your project. So the project was completed the last 6 months or whatever during the COVID pandemic. I wonder what impact the pandemic had on the way that you were managing the project and the way that you were executing the project.
Yeah, it was not easy. Just the erection part and supervising, the people need to come there. It's a new plant. There's not a team. We are sending some people from Turkey and suppliers also come to there, some contractors. We experienced many problems about that. I can say that. Some delays also happened. But we forced it and we try to control it. We take some precautions, try to keep it as close as possible, close the plant. The advantage is that there is social facilities and just the people can stay inside the plant. We keep the people just closed a little bit as much as possible because it's not also easy.
Now, I wondered if you'd used any remote support technologies. So, for example, from your vendors, whether they'd got experts to attend via video conference or the enhanced reality glasses.
Yeah, it just the video conferences. Yes, we did, and we got some support and video help on it. We couldn't have a chance to do it in here, but another project. We have a project in Aslan, kiln revamp project in Aslan cement plant near to Istanbul. We used that remote control eyeglasses on that project with the technology supplier. They connected from far distance, and a supervisor and our people wear that glass and just hear it and do it the directions of them. We did good jobs like that. It helped us so much, and I believe also it will help more in near future.
Yeah, I mean, it seems a very interesting technology because cement plants are usually in remote places, and you can deploy experts who are wherever they are in the world through this technology. It seems a big help to deploying the right people on each project.
These are also sophisticated technologies, but now we are working on it internally. We try to design it. Some audits can be done. Some far distance support. Visitors can just warn them or inform them by the help of that glasses. It increases efficiency and health and safety, and also far distance support.
Good. Well, I mean, I think it's encouraging that we see these new technologies. I think that COVID has accelerated the acceptance of these new technologies and forced us to start using them more quickly than it would otherwise have been the case. Anyway, Berkan, it's been a pleasure talking to you today, and thank you for sharing your experience on LC3, which I know many people are in the industry around the world are very interested by. And when I look at it from the standpoint of the industry as a whole, it seems to me that LC3 has the potential to really help us to reduce CO2 emissions significantly in the next 10 years, while we're still developing carbon capture, carbon usage technologies that might take us further than we know how to go today. So many thanks for talking to me today.
Yeah, thank you. It was also a pleasure for me. Finally, I also said that it's now we are experiencing. Before it's theoretical, but exactly it's now. I can say that it's when compared with Portland cement clinker, we can decrease. Currently, it's 70%, more than 70%, but there is also an option with the help of some secondary fuels, up to 90% less carbon dioxide emission footprint available cement product can be done with the as calcined clay, and the added cement, it's more than 50% less CO2 emission can be achieved. It's also important, and we believe that issue.
Berkan, many thanks.